Yeah, so my name is James Elder. I'm a professor and York Research Chair at York University. The chair is in Human and Computer Vision. And I'm associated with the Center for Vision Research at York, which is an interdisciplinary center which combines research on biological and computational vision. And in that spirit, actually, my appointment is a joint appointment between the Department of Electrical Engineering and Computer Science and the Department of Psychology. So the mandate of my particular lab is to try to build better computer vision systems through a better understanding of biological vision systems and in particular the human visual system. Like most professors, I love my work and our research. It's very much about bringing together science and engineering, and that's one of the great things about it. So as a neuroscientist, I'm learning and discovering new things about the brain and how we use our brains to, perform these complex visual tasks in a real complex environment. And so that process of discovery is really always exciting. At the same time, we're trying to build useful things, and that really brings out the engineering passion as well as enjoying building things and getting things to work well. The philosophy of learning from biological vision to build better computer vision systems becomes more important as we try to move toward more general purpose AI. So what we've seen in the last 10 or 20 years is really exciting new developments where AI systems are really effective at specific solving specific problems. Object recognition under constrained circumstances or natural language processing. But biological systems tend to be very general and able to do many things at once. And that's, of course, where we want to move in AI. So to get there, we think that we have to try to understand better how this is achieved in brains, like the human brain. Right now we have a diversity of research projects ranging from neuroscience to applications. A couple of the bigger things going on include a project we call ISUM, so that stands for Intelligent Systems for Sustainable Urban Mobility. And that's really about trying to harness the power of all of the video cameras we have in urban environments to better understand how people are moving around in complex urban spaces, whether they're walking, cycling, driving a car. And that's important for a whole host of reasons, for safety and security at intersections, but also for optimizing transportation systems. We also run a training program at York called the CREATE training program in data analytics and visualization. And so again, that is an integration of, on one hand, computational analytics to extract value from big data, and on the other hand, training in visualization. How do we transform those data to bring it to human perceptual and cognitive systems to facilitate effective decision making, for example. Living in Toronto, I feel very lucky to be, the center of major developments in AI in the last 20 years, let's say, particularly deep learning research that came out of the University of Toronto, Jeff Hinton and colleagues. And I was very, very happy to see founding of Vector, which enables Canada to try to take advantage of that really distinctive contribution and actually translate that research and continue to grow in that area. So, for me, I'm very interested in both the theory and application of AI, and so very excited to be part of Vector, which aligns with that interest. We've seen remarkable success recently particularly in supervised deep learning systems for solving specific problems. At the same time, there are challenges. So one big challenge is adaptivity. So here again, it's really helpful to compare machine intelligence to biological systems. Biological systems, including the human system, are extremely adaptive. We can move from one environment into another where everything changes, illumination, geometry, and everything. But we seem to be able to adapt to that new environment very rapidly. And current discriminative deep learning systems don't do that. So that's one of the challenges, and lots of us are working on enabling current machine vision systems, for example, to be more adaptive. Another, I think, challenge that we're going to be facing, or we're facing now, is trying to make machine intelligence more general purpose, instead of having a whole array of bespoke systems for very specific tasks. As we move toward the future, for example, social robots, we need to have systems that can integrate many different intelligent capacities into the same machine. And I think the third challenge we have is in terms of data and privacy. So I work in vision, and often where that arises is in visual surveillance. So none of us want to be feeling like we're constantly under surveillance, Big Brother's watching us. At the same time, sometimes we need visual security, just for safety. But we think there's a lot of opportunity where we can use vision to solve social problems and solve problems in our cities without compromising privacy. I think that's a really important and interesting challenge.